well, so let's switch gears. We got another really cool one here with us with Scrypts-Ai. So I'll pass it over to the Georgia Tech team.
Thank you very much. This has all been very interesting. So I think it's really good that we have this meeting now because I see a lot of common threads. So I'm going to start just with the project overview. So this project is on systems and cryptographic tools for scientific AI. And we have three main thrusts here. So we have SIPA, which is like systems level tools and infrastructure that facilitate integrity, provenance, and authenticity. And that means things like training logs for checkpointing, which is useful for replay infrastructure when you have large training distributed settings. Then we, in this thrust, we will also look at novel cryptographic schemes that enable integrity of training logs. So things like checksums, or training logs, things like cryptographic accumulators, signing, and checksums that can be used to obtain integrity, but with scalability at the same time. Another idea here is to enable or improve fixed point arithmetic, which is useful for cryptographic tools. I'll come back to that point later. So this is kind of the first thrust on systems. The second thrust is on integrity of data. So how do we ensure that we have some trust in how and where the data was generated? So for this, we are thinking of looking into cryptographic techniques again, which rely on zero knowledge proofs for certifying authenticity, as well as ensuring that there's no skewedness or bias in the way the data was chosen or ordered in training, which is a very important aspect in when you train models. It could actually result in worse models or models that are sort of malicious or attacker controlled. So how do we ensure proper randomization? And we're looking at things like hash chain, blockchain inspired techniques. Another kind of tool that we're looking at developing, and we've started work in this space, is watermarking approaches for data provenance, which allow you to get provable statistical guarantees to verify data provenance. And another aspect here is, which the previous project also mentioned, is unlearning. So we're looking at how do we verify unlearning, which is kind of appears in multiple regulations, but it's also useful because when you have data that might have been corrupted, or you figure out it's not the data that you want to keep, how do you efficiently update your models? And the last thrust is on basically post-training or the other artifacts that you may have after training. So it's ensuring AI model IPA or IPA integrity, provenance, and authenticity. So again, cryptographic techniques that tie in with the systems level. So assigning models this time to verify how models are where they come from and how they were generated. And another tool that we're looking to explore here is to repurpose privacy estimators from the differential privacy aspect to estimate correlations between the model updates and the user queries. You want to protect the sensitive attributes or sensitive features here. And what are the benefits? So the whole point of this project is to basically enable or design solutions that enable collaboration across disciplines. When you have data sets coming in from multiple providers that may be, distributed, sensitive, private, or noise from differential privacy. And we hope that this will enable scientific infrastructure to have more accountability and transparency, because now you have chains of how you got the model or how you got certain data. So hopefully that will enable more collaboration in the space of scientific AI, and also enhance confidence because we now have training logs. So you can go back and audit whether or not there is where that data comes from. So you can go and prove to a third party and reproduce the model if you need to. Also, data and model provenance together, tracking systems, and also we want to enable some property certification. So these are kind of the main benefits. And there are some challenges in this space because we're looking at potentially large-scale generative models as well. So LLMs, I'm going to talk briefly. I don't have a slide, but I'll talk briefly about what kind of models and data sets we're looking at. So large-scale generative models means very complex infrastructure for them and kind of a lot of compute resources. Also, floating point arithmetic, which is not really directly amenable to some of these cryptographic techniques. So how do we improve fixed point training to enable reproducibility? How do you maybe eliminate some non-determinism inherent in the training process? And of course, the need for user-friendly toolchain. So we're planning to open up all of this kind of crypto-inspired techniques and tools for other people to use. So how do we make them user-friendly? So we think it's going to have a high impact on scientific discovery because it enables securely sharing distributed data. And we hope it's going to also, because there's not just scientific data, there's also issues in the broader ecosystem for machine learning supply chain security. And we hope that this will become a success story of how to enable trust in supply chains of machine learning. And why do we need integrity, provenance, and authenticity? Well, this has come across also in the previous project, and I think in the call for this program, which is data privacy and security concerns are intrinsic to scientific data sets, medical being one very, kind of highlighted example, but it's not the only one. And also because there's potential for noisy or adversarial manipulation, right? When you have distributed settings, you want to kind of collaborate, but you may not trust all the parties involved in the collaboration. And there's currently very little or actually a lack of accountability and transparency in this domain. So we definitely need IPA. And then how are we going to approach this? I talked about the 3 thrusts to achieve this for AI data sets and models. And finally, how are we going to evaluate and demonstrate this? So we're planning to release our systems level tools and infrastructure. So as like end-to-end tool chains to basically provide these capabilities. And also kind of making, publications where we release our mechanisms, implementations, and benchmarks, right? The algorithm, as well as the source code, will be available on GitHub, as long with its generated artifacts and the paper under an open source license. So this project starts in January 2026, and it's led by Georgia Tech, and it's in collaboration with UCLA. So I mentioned the team at the beginning as well. And maybe I have a couple, like 30 seconds or so to talk about the data set part.
Of course, yeah.
Okay, great. So we're planning to work on public data sets. So, and this include not just kind of the traditional machine learning or kind of computer vision models, but also looking at generative models or like language models. So specifically, we're looking at some kind of AI for science assistant type of models that allow you to look at question and question and answer data sets where the model is learning chemistry or other things. So we're looking at those kind of data sets. So these are publicly available, but also things like HTAN, which is HTAN data sets, which is part of the National Cancer Institute initiative to construct basically atlases of scientific data sets as well. So we're looking at those kind of data sets. And Biotrove is another data set which is used for scientific discovery. So these are publicly available. So we're planning to use those and kind of do our proof of concepts and implementations and tool chains on these data sets. And of course, we're open to look at other data sets as well. So I was taking a look at after the presentation at least on NDP and the other platform, whether or not there are some data sets that we could use. And I did find some that are cancer related, which will be potentially interesting for our collaborator at Emory University. So from the hospital side, but that we will have to discuss with our collaborator.
Fantastic. All right. So, and that's good. And thanks for taking a look at that already and kind of seeing how this is part of the overall objective, right? Is it's I was talking with a colleague last night. It's the classic comment about standards, right? The famous standards quote is the great thing about standards is there's so many to choose from, right? Which is actually not a great thing. We're looking at similar issues in data is that we really like that we're kind of pushing a more common data platform access and common things. So appreciate you already kind of taking a look at what's out there on NDP and OSDF, and I think this will be great. Uh, yeah. Um,
Yeah.
yeah, Brian. Yeah, looks
Yeah,
like.
just to build on that a little, when you're deciding what data sets to work with, forgetting, if you had a magical genie that could find any of those that actually exist, what do you look for? What makes for an interesting data set for your project?
So I think the first aspect to consider will be modality. So whether it's image data sets or language data sets. So for example, when I'm talking about LLMs and kind of this more scientific discovery type versus predicting whether or not you have a disease, which has focused more on like the image domain, that's one important aspect. So for example, this is important because the tools that you might use for the data might be different. So watermarking images will be different from watermarking text in the way we construct those primitives. For the cryptographic side, it may not be so different, right? Because you are supposed to, at least at the level, a conceptual level, but it might be different in terms of how it scales. So we're looking first probably at image data set and then looking at text data sets because that's kind of like the next frontier. And we're going to look at, first of all, they have to be public so that we can use them. And yeah, that's how we're gonna in this order we're gonna pick them. And the ones that I'm talking about are kind of the ones that are available publicly. So they may not be the biggest ones or the most useful ones, but the ones that we found. So the ones that I mentioned and just now they have been tried, so they have like models have been trained, so we're going to walk on a path that is known in the sense that we can get models that have good performance for the scientific tasks, and we're going to start from there because eventually like what we want to show is the uses of our tools and not something that doesn't work because it's such a new data set, a new model to work with that we cannot even get it to train.
Let me see how you envision it all working. Let's assume that we have a researcher that is generating images and they want to watermark them. How will it work? The images are coming off the machine, and they collect hundreds of them, thousands of them, hundreds of thousands of them. Uh, do you see them pushing them through some machinery that will watermark them? And who will and how easy would it be for a consumer to figure out whether this image is to identify the watermark?
So the schemes we have currently played with assume that the watermarking scheme, you can think of it that there is a key associated with it, and that key currently belongs to the user. So each data set provider, let's say you have your own data set and you want to watermark it such that at the end of the day you'll say this model was trained on this data set, and I can prove it to you because I will give you like the public, maybe it's like some sort of private public key, but I can.
Yeah, but beyond training, I mean, I think we personally that we focus on training, but there is inferencing I mean, data goes around, and you are saying that having provenance on the data and watermarking it is going to be extremely valuable. So I wonder, and maybe we should talk about it offline, is how do you make it work end to end? Because in our world, we have researchers that generate quite a bit of items in the data set. And if you want to bring watermarks into this ecosystem, there is a question of how it works end to end and how do you distribute the keys and all these things that may make and break it.
Let me say, I think this is a really fascinating, good conversation, and I think I'm actually really excited about the marking concept here. But I think maybe this is something we should push offline for further discussion. But it's definitely some interesting stuff here.